Okay, Assalamualaikum and hello everyone. So in this video, I will continue with lecture 4.2, Determinant of Matrices. Okay, so in this video, you're going to learn how to find determinant for 2 by 2 matrix and 3 by 3 matrix. Okay, so first of all, let's go through 2 by 2 matrix. Okay, let's say we have matrix A with the elements A, B, C and D. So the determinant denoted by this symbol is simply equal to A multiply D minus with B multiply with C. So this is the formula for determinant of 2 by 2 matrix. So let's try to example. Let's say we have this matrix A and matrix B over here. So when you see this symbol for matrix, we know that we need to find the determinant. Okay, so let's try first the determinant of matrix A. So based on formula, it says that AD multiply BC. So AD multiply BC. So I simply multiply 2 with 8 and then minus 5 multiply with 3. So we get 16 minus 15 is equal to 1. Okay, same goes as matrix B. So we have 3, 2, 5, 2. So the formula is AD minus BC. So 3 multiply 2 minus 5 multiply 2. So 6 minus 10 is equal to negative 4. Okay. This is how you find the determinant of 2 by 2 matrix. Okay, so now let's proceed with determinant of 3 by 3 matrix. So before that, we need to know what is minors and cofactors of a matrix. Okay, so we start with the minors. So minor Mij of element Aij is the determinant of the matrix obtained by deleting the ith row and jth column from some larger square matrix. Okay, so let's go straight to the example. So let's say we have this 3 by 3 matrix A. So let's say we want to find the minor M11. So this means we have to find the determinant when we delete the first row and first column. So we need to delete first row and first column. So we just need to find the determinant of the rest of the element, which is 1, negative 3, 0, 4. Okay, so based on the previous formula, how to find the determinant of this? AD minus BC. So this one multiply with each other, minus 0 multiply negative 3. Okay, so 1 multiply 4 minus 0 multiply negative 3. So you can get 4. Okay, let's try again. So now we want to find the minor M12, meaning we have to find the determinant when we delete the first row and second column. The first row because it is I and the second column because J is equal to 2. So we just need to delete first row, second column, and then we have to find the determinant of rest of the element. 2, negative 3, negative 2, 4. Okay, so using the formula, we're going to use AD minus BC. So AD minus BC. So 2 multiply 4 minus negative 3 multiply negative 2. So we get 8 minus positive 6, we get 2. Okay, let's try another example. Let's say we want to find M21, minor 21, meaning we have to delete the second row and the first column. So delete the second row and first column. So what's left are element negative 1, 0, 0, 4. Okay, by using the formula AD minus BC, so we have negative 1 multiply 4 minus 0, so we get negative 4. Okay, let's try the last one. For example, we want to find the minor 1, 3. Okay, so this means you have to delete the first row and third column. The first row and third column. So the elements that are left are 2, 1, negative 2, 0. So using the formula AD minus BC, so multiply 0 minus negative 2 multiply with 1, you're gonna get 0 plus 2 is equal to 2. Okay, so you can try by your own for the rest of the minor. For example, you need to find the M2, 3, and then you have to find the M22, M3, 3, and so on. Okay, you can try by your own. Okay, that's it for minors. Okay guys, so now let's proceed with the cofactors. Okay, so the cofactor Cij is actually equal to negative 1 to the power of I plus j, and then multiply with minor ij. So for example, we want to find the cofactor 1, 1 is equal to negative 1, 1 plus 1 minus 1, 1. Okay, so negative 1 to the power of 2 is positive 1, so it will become positive minus 1, 1. Okay, next one, let's try cofactor 1, 2. So negative 1, 1 plus 2, multiply with minus 1, 2. So negative 1 to the power of 3 is negative 1, so we're going to get negative minus 1, 2. And then the last one, let's say we want to find the cofactor 1, 3. It is equal to negative 1 to the power of 1 plus 3, multiply with minus 1, 3. So negative 1 to the power of 4 is positive, so we're going to get positive m1, 3. Okay, so notice here that actually, if the sum of your row and column is even number, you're going to get positive. And then if the sum of your row and column is odd number, you're going to get negative. Okay, so if your sum of your row and column is even number, you're going to get positive. And if the sum of your row and column is odd, you're going to get negative. Okay, let's try it. Let's say I want to find C to 1. So 2 plus 1 is odd number, you're going to get negative. So it's equal to negative minus to 1. Okay, and then let's say I want to find C to 2. So 2 plus 2 is even number, so you're going to get plus. So it will become plus m to 2. Then last one, let's say I want to find C 3, 2. So 3 plus 2 is odd number, so we're going to get negative. So it will become negative m3, 2. Okay, as simple as that. Okay, so now let's try example 6, which the question asks you to find all the cofactors of the elements in the first row of matrix. The first row of matrix, okay, which is this one. This is the first row. Which is at the first row, we have the element A11, A12, A13. So we need to find the C11, C12, and also C13. Okay, so based on the previous formula, C11, so 1 plus 1 is even number, so you're going to get positive. So positive minus 1, 1. And for this one is negative m12, and for this one is positive m13. Okay, so you already learned how to find the minor. Okay, so for example, the first one, C11, it is positive m11, so you have to find the determinant when you delete the first row and first column. So you delete the first row and then the first column. So the determinant is the determinant for 1, negative 3, 0, 4. And using the formula AD minus BC, 1 multiply 4 minus 0 multiply negative 3. So you're going to get 4. Okay. Now moving on to next one, which is this one. So you have to find the minor 1, 2. So you still have the negative. So the minor 1, 2 meaning you have to find the determinant when you delete the first row, second column. You delete the first row, second column. So the first row and second column. So what's left are 2, negative 3, negative 2, 4. Okay, so based on formula, we just need to multiply AD and then minus BC. So 2 times 4 minus negative 2 multiplied with negative 3. So you're going to get negative 8 minus 6, so equal to negative 2. Okay, so the same step for this one, so you can try by your own. So you're going to get your answer is 4. Okay, alright, that's it for cofactors. Okay, now let's try example 7 together. So it is given matrix A is equal to this, and these are the elements. So we need to find the A11, M11, and C11. Okay, so I believe everyone still remember what is A11. So this is the element of matrix at row 1, column 1. So this is your element, so it's equal to 1. Okay, and then we need to find the minor 1, 1, meaning we have to find the determinant when we delete the first row, first column. First row, first column. So 6, 1, 4, negative 7. So the formula is AD minus BC. So 6 multiply negative 7 minus 4 multiply 1. So we get negative 42 minus 4 is equal to negative 46. Okay. And then the last one for C11, cofactor 1, 1. So 1 plus 1 is positive. Sorry, 1 plus 1 is even number. So when even, we're going to get positive. So positive minus 1, 1, 1. So positive. 1 plus 1 is positive. 1 plus 1 is even number. So when even, we're going to get positive. So positive minus 1, 1, 1. So positive. 1 plus 1 is even number. So when even, we're going to get positive. So positive minus 1, 1, 1. So positive. 1 plus 1 is even number. So when even, we're going to get positive. So positive negative 46, so it's equal to negative 46. Okay, now let's try another one. Okay, so the next one, they want you to find a to 1, minor to 1, and cofactor to 1. So element to 1 is element where belongs at second row, first column, second row, and then first column. So it is 4. The answer is 4. Okay, and then for the minor to 1, you have to find the determinant when you delete the second row and first column. So you delete the second row, first column. So what's left are these elements. So 5, negative 2, 4, negative 7. So using formula AD minus BC, minus 4, negative 2. So you're going to get negative 35 minus negative 8 equal to negative 27. And then for the cofactor to 1, 2 plus 1 is odd number, so it will give you negative minor. So negative m to 1, so negative, and then your minor is negative 27. That's how you get 27 as your cofactor. Okay, so for the last one, I want you to try by your own. So the answer for this one is 3, and this one is 17, and this one is also 17. Okay, so you can try by your own for this one. Okay, that's it for example 7. Okay guys, so you have learned about the minors and cofactors. So now we can find the determinant of 3 by 3 matrix. Okay, so the 3 by 3 matrix can be evaluated as the sum of products of elements of any row or any column with their respective cofactor. Okay, so let's say we have this matrix over here. So the determinant of this matrix is simply, you can choose any row or any column, and then you need to sum up the elements and their cofactors. Okay, for example, in this example, they use the first row. They choose the first row to calculate the determinant. So the formula is each element multiply with their cofactor, and then you need to sum up. You need to add all the products. Okay, so there is one important tip over here, which is you can make your calculation easier by choose any row and column that has the most 0. Okay, you're gonna see why. So let's straight go to the example. So let's say we have this matrix over here. So let's say which row or column that has 0 or the most 0. So you can clearly see, you can choose this one, the second row, because it has 0 on it, or you can also choose the second column because it also has 0 on it. Okay, so I'm gonna show you both methods so that you can see that they will give the same answer. It doesn't matter any row or any column. Okay, so method 1, we're gonna choose the second row. So let me highlight the second row first. So we're gonna choose this row. Okay, so the determinant of A based on formula, since we choose this row, so this is a to 1, a to 2, and a to 3. So the formula is going to be a to 1 multiply c to 1 plus a to 2 multiply c to 2 plus a to 3 multiply c to 3. Okay, so now we're going to change the cofactor into minor. So c to 1 is negative m to 1, c to 2 is positive m to 2, and then c to 3 is negative m to 3. Okay, so I'm going to put the negative at the front, so it will become negative a to 1 m to 1 plus a to 2 m to 2, and then minus a to 3 m to 3. Okay, I've changed the cofactor into minor by using the previous formula that we have learned. Okay, so now we're going to insert the value. So we have negative, so a to 1 is negative 3, so multiply negative 3. And then for m to 1, you have to find the determinant when we delete the second row, first column. So second row, first column. Okay, so this is your element, and then you're gonna delete the second row and first column. So what's left are negative 5, 1, 5, negative 4. Negative 5, 1, 5, negative 4. Okay, and then plus a to 2 is 0, so you simply write 0. No need to write this one because 0 multiplied with anything will always be 0. So you just proceed with the rest, which is negative. And then a to 3. A to 3 is 1. So 1, and then multiply with minor to 3. So you have to delete the second row, third column. So we have 2, negative 5, 2, 5. Okay, so now we're going to calculate. So this one become positive 3. And then using formula AB minus BC for this one, you got to get negative 5 multiplied negative 4 is 20 minus 5. And then minus, we calculate AD minus BC for this one, we're going to get 10 minus negative 10. 10 minus negative 10. So we will get 25 as our final answer. Okay, so this is the determinant by using second row. Okay, now let's try the same matrix but using different column. So we choose the second column this time. So I'm going to highlight the second column to find the determinant of this 3 by 3 matrix. So based on formula, since we choose the second column, so the second column here is A12, A22 and A32. So the formula is A12, C12 plus A22, C22 plus A32, C32. Okay, now I'm going to change the cofactor into minor. So C12 is negative M12, C22 is M22, and C32 is negative M32. Okay, so it will become negative A12 M12 plus A22 M22. Last one, negative A32 minus 32. Notice here that your sign will always alternate. Okay, akan berselang-seling. For example, this is the same. And this is also alternate, negative and positive. Okay, so now we're going to insert the formula. So negative, A12 is negative 5. And then the minor when we delete the first row, second column. So we choose negative 5 and then we're going to delete the first row, second column. So 3, 1, 2, negative 4. And then plus 0. So no need to insert the minor. And then last one, negative. This is your A32, so 5. And then the determinant is when we delete third row, second column. When we delete third row, second column. So 2, 1, negative 3, 1. 2, 1. 2, 1, negative 3, 1. Okay, so same step as before. You just calculate using the formula AD minus BC and you will get the same answer, which is 25. Okay, so this is the formula for determinant of 3 by 3 matrix. So remember, you can choose any row or any column, but it is preferable or it is important that you choose any row or column that has the most 0 because it will save your time. And okay guys, so we are at the last part of the video. So we're gonna learn about the properties of determinant. Okay, so there are 7 of them in total. I'll go through one by one. Okay, so first property is that the determinant of matrix A is actually equal to the determinant of matrix A transpose. So for example, we have matrix A over here and the determinant is equal to 90. So they want us to find the determinant of this matrix. And notice that this is actually A transpose. They've changed all the rows become the column of the matrix. So this is actually A transpose. So the determinant of A transpose is actually equal to the determinant of matrix A, so it's equal to 90. Okay, they will have the same determinant. Okay, the second property is the determinant of matrix A multiplied with B is actually equal to determinant of A multiplied with determinant of B. So for example, we have determinant of A equal to 90 and determinant of B equal to 12. They want us to find determinant of matrix A multiplied with B. Okay, so based on properties, it is simply determinant A multiplied determinant B. So 90 multiplied with 12, it is equal to 1080. Okay, so the third property. So let's say A is a n by n matrix and K is a scalar. So the determinant is equal to K to the power of n multiplied with determinant A. Okay, so what does it mean? So let's say we have matrix A is equal to 90 and then we have another matrix. This is 3 by 3 matrix. And then notice that each element of the original matrix A is multiplied to constant K equal to 3 to get this new matrix. Okay, so for example, 2 times 3 is 6, 6 times 2, 6 times 3 is 18, 5 times 3 is 15, and so on. So each element in the original matrix is multiplied with constant 3 to get this new matrix. Okay, so based on properties, the formula. So now the new determinant for the new matrix is simply equal to K to the power of n multiplied with the original matrix the original determinant. So your k is 3, and then your n is also 3, so 3 to the power of 3, and then multiply it with the original determinant, which is 90. So equal to 243. Okay, so this formula is only applicable if the constant k is multiplied to each element of the original matrix. Okay, so now let's say we have only one row or one column that is multiplied to the constant k. So what will be the determinant? So for example, this matrix A over here, they only multiply the first column with constant 2. So in this case, your constant k is equal to 2. So 2 times 2 is 4, 9 times 2 is 18, and a plus 2 is 2a, and the rest of them is the same. So if this is the case, your determinant gonna be k multiplied with the original determinant. So 2 multiplied with 90, you're gonna get 180. Okay, same as this one. For this one, they only multiplied the first row with constant k equal to 2. So 2 times 2 is 4, 0 times 2 is 0, 3 times 2 is 6, and the rest are the same. Okay, oh wait a minute, sorry. They multiply the first row with 2 and the second row as well with 3, is it? With 2, yes, with 2. So this is also equal to 2. Okay, so they multiplied the first row with 2 and the second row as well with 2. So based on formula, you're gonna multiply k, the first k, and then the second k, and then the original determinant. So you're gonna get 360 as your determinant. Okay, so that's the third property. So the next property is number 4. So the value of determinant changes sign if two rows or columns are interchanged. Okay, so for example, we have matrix A, and the determinant is 90. So notice that over here they want us to find the determinant of this new matrix, and they only interchange the row. They change row 1 and row 2. They change the place. So based on the formula, based on the properties, your determinant gonna become negative 90 because you just need to change the sign. Okay, so number 5, if every element in a row or any column is all 0, so determinant is simply 0. For example, we have this matrix over here. So you notice that the third column is all 0, so you can conclude that it will always equal to 0. Okay, so number 6, if any two rows or columns are identical, your determinant is also equal to 0. For example, this matrix, we have the same exact row 1 and row 3, so you can directly conclude the determinant will always equal to 0. And then number 7 is if matrix A is upper triangular matrix, lower triangular matrix, or diagonal matrix, then the determinant of the matrix can be obtained by multiplying the elements on the leading diagonal. So I believe everyone still remember what is the leading diagonal. It is the elements over here. Okay, so for example, we have this matrix B and they want us to find the determinant B. So based on the properties, so this is actually a lower triangular matrix, okay, because we have elements on the lower triangular and the rest of them are 0. So based on these properties, you can simply find determinant by multiplying the elements on the main diagonal. So it's equal to 3 multiply negative 2 multiply negative 5 multiply negative 2, which gives us 30 as our determinant. Okay, so that's it for 4.2. Bye guys.